So one of the questions we had a lot about was uh, when we're looking to get quotes and buy filters, there's a lot of confusion about sizing, measuring, things like that. How do we use the term diameter for the bag? Some people call flat width. Some people don't understand the difference between the diameter that is the tube sheet hole size, the bag diameter, the cage. So, um, what can we say there, Matt? How do we define when somebody asks us to get a bag and they say we tell them we need the diameter, the length, and the flat width? What do all those terms mean?
Sure. So the first thing to know is if you're not sure, you can ask whoever you're interacting with here in our company. If it's Andy or Scott or Dominic or myself or Dave, if you're not sure, we'd be happy to explain it to you. But just to do a kind of quick and dirty answer there. So the diameter is just that distance across the circle of your bag or your cartridge, which you can measure directly with a tape measure, or if it's a fabric bag, it might not be that easy to measure. So what we ask you to do is lay it flat, take a tape measure and measure right across that width, which is the flat width. And with that, we can calculate the diameter. The length, typically we'll ask for the length from the bottom of the bag to the top, or the top or the snap band where it snaps into the tube sheet. Pretty straightforward there. You just lay the bag out on the floor and measure with the tape measure. Occasionally there's some other dimensions we need. The best possible scenario is if you have an extra bag, you can just send it to us. That way we can get it to the filter shop and let them match the snap band diameter, the width, the flat width, all those things. If you send your bag over here to Scott, he can take those measurements for you and we can confirm it will fit, because some of those measurements are easier to take than others. Did I answer the
Awesome.
question?
Yeah. There also were some questions too about when we're talking about snapband bags. There's some confusion between diameter of the bag versus the tube sheet hole diameter, or they don't know what the tube sheet hole diameter is, and is it the same as the diameter of the bag? I don't know, Scott. Maybe you could tell us what's the tube sheet hole measurement and why is it so important for us?
Yeah, so you can kind of see in the diagram of the baghouse drawing that's on the screen here. We can't hold a bag perfectly in a circle, so it's very difficult to be able to take a very accurate tape measurement of our bag. So one thing that will go off, especially if it's a snap band style bag, which is one of the bag styles that we have for a pulse check baghouse, is we'll ask you for, with the calipers, the diameter of the tube sheet. That's where the bag will snap into the metal plate that divides the clean and the dirty side of the baghouse. So you can kind of see that there. Some people call it a different name, like a cookie sheet, or where the bag snaps into. We usually call it the tube sheet. We'll need to know that measurement as well. We want to make sure that we get that exact measurement. If it is a little bit too small, our bags will then leak. They won't be able to perform or have a perfect seal. If our bag is slightly too big, it'll actually have like a little crease and won't be able to snap perfectly into that tube sheet, again, causing leaks, things like that. The other option that Matt had said is that you can send us a bag as well, and we can make an exact replica. If we're unsure about the tube sheet diameter, like maybe we can't actually get in there because the baghouse is running 24/7, or we don't have a dirty bag to send, we can actually send you a sample, a pre-production sample, to be able to put the bag in there, make sure it fits well. If it doesn't, adjust it slightly and take it from there. But we want to make sure that diameter, that bag snaps perfectly into the tube sheet of the baghouse.
Awesome. And I think I'll just add there was some questions too about sizing the cages. So when we have a snap band, a pulse jet bag house, the top load, they use snap band bags. Obviously, the cage fit is important. So it's really like a series of things we have to size. So the very first thing is that hole size, right? We get that hole size. For example, our collectors and a lot of other major brands, we use a industry standard 6.25 inch tube sheet hole. So that's our biggest part. And then we have our bag, which has to be a little bit smaller. So that's usually 6 inches or 5 7/8 actual diameter of the bag. And that works out to about a 9.25 flat width. And then from there, now we need the cage, which needs to be smaller than the bag to go inside, right? So The bag diameter or the cage diameter is usually about an eighth to a quarter of an inch smaller than the bag. So a very common combination. This is what our units use. A lot of other brands is 6.25 inch hole, a 5.875 diameter bag, and then a 5.625 diameter cage. And that gives us that nice like eighth inch, quarter inch, what's called pinch, or how much you can pinch off of the cage. So whenever you call us to ask for a bag quote, those are the measurements we're going to need. And sometimes it might seem like we're asking for more and more. That seems unnecessary, but it's because a lot of times there's like, what do we call it? We call it size creep, where over time everybody measures it a little bit more sloppily. And slowly people get bigger and bigger bags or different mismatches between the cage and the bag. And how tight that bag is to the cage is really crucial for the snap band, the pulsing. I'm sorry, for the pulsing action. When it pulses, the bag snaps back on the cage. It's really important that distance, that's oversizing of the bag, be right in the range it needs. Otherwise, the cleaning won't work well. So we might ask you to verify the cage diameter. And if we do that, we're going to ask you to measure it in the body of the cage, usually not at the very ends, because some manufacturers make the cages get just a little bit smaller at the bottoms. So that way we can make sure all of those things line up in the right sequence from the smallest, the cage, to the next size up, which is the bag, to the tube sheet hole, to make sure everything is all matched together. Okay, well, thanks guys for those answers. Let's go into another one. We talked about this a little bit in the briefing, but maybe just real briefly, Matt, what would you say? Somebody asked about what's our average lifespan for a baghouse filter versus like a cartridge or a pleated bag? What would you say average lifespan should be?
Well, the sort of kind of semi answer I usually give is that a rough middle of the road estimate of about a year is fairly reasonable, but of course it depends. So the fully lawyerly answer is that it depends, right? So like I said earlier, if you're running it hard, a lot heavy dust loading, 24/7 operation, abrasive dust, temperature spikes, all the worst things you can think of. If you're throwing the whole kitchen sink at it, you might have to change your filters every 2 weeks or every month. It really just depends. If you've got, your sort of wood shop, tool shop that gets used once in a while and it's getting some light, fluffy dust and used once a day or so, heck, those filters could last for several years. It really just depends. You're really going to want to talk to someone who can take a look at your application and your system sizing and all those factors and figure out what the best filter is for the application, and who can probably give you something like a better estimate of how long you can expect the filters to last.
Excellent. Yeah, it also impact too is if the system is undersized or not maintained well, then that's gonna shorten the lifespan of the bags quite a
Definitely.
bit. Yeah. Kind of along those lines, we had some requests, some questions that came in about how to identify damaged bags. So what solutions are there for finding bags? A lot of people wrote in saying, when we have a leak, it's really hard, takes a lot of time to go find the leaking bag. How do I find a leaking bag in the midst of hundreds or thousands of filters? What would you say?
So the easiest way is to do a dye leak test. It's very simple. Yeah, I understand not every customer can do that. Sometimes if you're recycling the dust out of the hopper and it's going into your product, you may need to look closely and see if that'll work for you. But for most people, they can. Basically, you just take this powder, which is colored powder. It shows up under UV light. So you suck it into your bag house. You can introduce it through the upstream ductwork and let it coat your filters. Let it run for a few minutes, then you shut your system off. You go into the clean air side or the clean air plenum of your bag house with the UV light, a black light essentially, and you basically play detective. You run it along until you find the indication of that powder where it's come through the filters. And usually you'll find that there's the filter. You can identify 2 or 3 spots. Sometimes you'll see around the interface between the filter bag and the tube sheet, there'll be a little indication. So that's definitely much easier than trying to track and trace a leak based on signs of dust in the clean air plenum, which can be swirling around in there. It's nearly impossible most of the time. So the leak test powder is the way to go. You hit the clean air plenum and find it that way. You can also go into the dirty air side, and you can see where the dust has collected onto one particular cartridge. Say if there's a really big leak, you can see that everything wants to go to that leak, so it'll be coated with that UV powder stuff, and you can pick it up pretty easy. It is important that you have a good light, high wattage light, the darker the better. So if you can enclose yourself into the clean air plenum using obviously appropriate confined space entry procedures and everything, but basically you just want as little light as possible so you can see that stuff under the light.
Yeah, me and Scott just came from a customer where they were having problems finding the powder, and we recommended that they go on the dirty side sometimes when there's a difficulty finding it. That sometimes is the only option. It's better to be on the clean side, but sometimes you need to go on the dirty side too with the light. And I would just add sometimes too, not enough powder is used, right? We've seen that before. And follow the calculations, roughly 1 pound for every 1,000 square feet that you have. And then that makes sure you get proper coverage, and also where you inject it, right? Inject it upstream of the bag house if possible. If in a pinch, you can put it into like a hopper kind of injection port on the bag house, but it's much better to put it in the ductwork so that it distributes, evenly everywhere. Somebody asked too about monitoring for emissions, and it kind of goes along with this, there are different ways to monitor what goes out of the stack. But the best one is what we call triboelectric emissions monitors, or sometimes just called triboelectric leak detectors, because that's actually their main purpose is detecting leaks. So the dye testing is like the maintenance way of doing it. The tribo detectors are sensitive enough that they can tell you when a leak is starting to form in the unit far before you'll see some coming out of the stack. They'll let you know that it's starting to rise. But also on larger systems, they can be really useful for locating the leak down to a specific compartment or even down to a specific row of bags. When it's pulsed, that row, you'll see a big spike on the triboelectric detector. And that's why we call them a leak detector. And then it narrows it even faster and even more precisely to just one specific row of bags where you have your problem. So a lot of people use them for the maintenance reasons. You can also use them for the emissions monitoring as well. But those two things together, the bag leak detectors and the dye testing, that's really the gold standard for how to find a leaking filter quickly. Related to that, we had some questions about changing bags and damaged filters and things like that. Something that comes up a lot that we talk about is spot changing. So that's where you have one leaking filter or maybe a few leaking filters in a bag house. And as Scott mentioned his part about the nail in the tire, what do we do? So we usually recommend you obviously have to change that filter. We can't leave it leaking. But Scott, maybe you can tell us a little bit, what's one thing we have to be careful of when we're spot changing filters in a larger system? What do we want to avoid doing too much of?
Yeah, we definitely want to use it as the exception and don't, let it become the rule. We talked a little bit about in that section the dust cake that naturally forms on the filters. A little bit of dust, a little bit of buildup on your filters is, actually very good. Why we don't necessarily need to only have clean, pristine filters on the dirty side is, if we do spot change our filters like that, a lot of times it will change the airflow, for example, how the air is going through from the dirty side to the clean side. And obviously, if we have a nice, clean, pristine filter, more air is going to naturally go to that filter than the other filters. So essentially, spot cleaning, again, we only want to use it as an exception because essentially we're going to wear out that new filter so much faster. Wear out that filter, we have to change it, we have to change out this, we have to change out that. It just becomes a vicious cycle of we just need to change out all of our filters to be able to, make sure the bakehouse is functioning correctly.
Yeah, exactly. We actually say a lot of times it leads to like cascading failures, right? If you keep doing it. So it's kind of like the necessary evil, like it's like putting the spare tire on your car, right? It's there to get you to the mechanic so you can put a real tire on, but you can't drive at full speed. It's going to fail. If you try to just drive around with one little dingy tire and three big normal tires, right? It's going to cause problems, right? Another question is one more on filters here. Matt, somebody had asked, we've talked about early filter failure, when we need to change those filters. How do we know when filters reach the end of their life and we have to change them? What are the signs that the filters are blinded and at the end of their life?
So this question is right out of our Baghouse 101 training materials, right? So what the most fundamental thing we look at to evaluate how a baghouse is operating and how it's running is the differential pressure. So you will see over time the DP gauge will go up and then it'll go down as the filter cleaning system kicks in, right? It'll go up and down. And if you're plotting it on a graph over time, you'll see this sawtooth. It'll slowly over time go up and down, but it'll trend upward. In a certain point, your filter cleaning system will no longer be able to adequately clean the bags because it's got those entrained particles that just aren't being released with the pulse air. And that's a sign that it's becoming blinded. And there's a certain point where it'll be up at a high differential pressure and the cleaning system will not be able to bring it down to your desired set point. So maybe it's up at 6 inches, your cleaning system's struggling to get it down below 5. There's a certain range and it's going to be dependent on your system and your application, but that is the metric to use, your differential pressure. When it gets to that high point, it's time to change your filters.
Yeah, good explanation. And like we said too, sadly, there's a lot of facilities where people have never even seen that, right? Because
Yeah.
for whatever reason, their filters are always getting holes and stuff like that. So they've never even experienced that where it's at the end of their life. Um, some of the larger applications where they have big reverse airbag houses, they're able to plan this out months, even years in advance because they're carefully watching the differential pressure. They have it all trended. And they even monitor also the emissions coming out, and they can predict pretty accurately on those kinds of systems months and years when they're going to fail, and that's how they can schedule those change outs at a convenient time.
Yeah. Can I add, Dominic, just one or two
Yeah.
quick other things? So on that point, most of the timer boards that are, they come along with your baghouse in this day and age will have a differential pressure readout, like a digital readout. And it's important to make sure that you're getting good readings. The way those work, it's very simple. It's just 2 air tubes. But if they get blocked up or the tube cracks and you get an air leak, your differential pressure reading, which is your most fundamental baghouse safety, health measure, may be not reading correctly. So I always point out to people, number one, make sure that you're maintaining those air tubes and you're testing the DP reading, either with a separate gauge or there's a couple little tests you can do. And then one other thing, most of the timer boards out there nowadays also have an analog output. So you can run a 4 to 20 milliamp signal to your control room or wherever you want it to go. So somebody can pull up a report or log that or check it. You can signal an alarm. There's a lot of stuff you can do. Just the basic Dwyer boards that you can find, the turbo boards all have that analog output that you can send to your control room, so you can do that trending and analytics if you have the desire to do that.
Yeah, that's a good point. Thanks, Matt. Let's talk a little bit about cleaning systems now. Somebody asked this question. They talked about the specifics of the cleaning settings. They said, what is the proper compressed air pressure for bag cleaning versus cartridges, their difference? And then what about the things like the on time, the off time, the cycle timing? What would you say, Matt?
So there are some differences. So general recommendation, I usually look for 90 to 100 PSI. There are a couple of OEMs out there for cartridges that run a little bit lower pressure. So, check your OEM manual, but if you have 90, 95 PSI, you should be just fine for a baghouse cartridge collector. You're in the right range. As far as timing, that will kind of depend on your application. So whoever you buy your system from, you should ask them. They will probably come pre-programmed based on your blowpipe and your pulse valve size. The actual open time for that will be determined by that. So whether that's 20 milliseconds or 100 milliseconds, it depends on the diameter of your connecting, your blowpipes and pulse valves. The downtime or the wait time that will kind of depend on how heavily loaded your bag house is. You know, if it's not uncommon, we'll go do an inspection and we'll hear them pulsing every 10 seconds, which is too fast for almost every application. It's maybe just a default setting on the
Yeah.
Dwyer timers or whatever it is. Um, like I said before, I think clean on demand is best. So you're not
Yeah.
activating your system until it's needed. But there are systems out there that don't have that capability. There's no pressure module, so it's just a timer. And I would say, again, just to throw a middle of the road answer, 20 to 30 seconds, you know, is probably on the low side, maybe even higher. But you're going to need to look at how your differential pressure is responding. If you're getting high DPs, maybe your cleaning system timer should be, you know, tightened up a little bit so you're getting more
Yeah.
pulses.
Yeah, I would just add to that that off time, sorry, the on time is one of those things. It matches the valves, and then you should never touch it. But sometimes
Yeah.
people have the mistaken idea that if I open the valve longer, it'll make the pulse more powerful, and it actually does the opposite. Because instead of a nice punch from the high pressure air coming through, you end up getting like a kind of weak, like kind of, and it doesn't really have that punch
Definitely.
that gets the dust knocked off. And then the off time, how long it waits between pulsing. When you do have it in clean on demand, we get this question a lot. When you do have it on demand, it doesn't really matter how long it is. It should actually be quite short. It really just needs to be long enough for the air header tank to refill to max pressure between each pulse. But as long as it's got enough time to do that, the shorter the better, because when the clean on demand starts, you want it to clean as fast as possible and get its job done and then stop. It's not really controlling how much you clean when you have it in the clean on demand mode. It's just how long it lets the valve or the tank refill with air, right? So if you have demand on demand, the off time not really all that big of a deal. Um, let's go to some questions about applications and system designs. We had a question here about filter bags, how we decide what's the best kind of filter for our application. Maybe Scott, could you walk us through?
Yeah.
We usually say there's five, I think it's 5 steps that we tell people
Yeah.
that we go through to find the right bag. Can you walk us through those?
Yeah, we don't have a one size fit all approach. There's a couple of different things that we need to keep in mind when we look at our filter media or the fabric type. The first one that we would consider would be the temperature. Do we have a high temperature or a low temperature application? Low temperature would be anything generally up to 250 degrees Fahrenheit. High temperature would be anything above that, generally to about 500 degrees Fahrenheit. So we need to know what type of fabric can withstand those types of high temperatures if we have a high temperature application, for example. The second thing that we look at would be the chemical makeup of the airstream. Basically, what type of a dust is going through it? What material is it? Is it some sort of acidic dust? Is it some sort of alkaline, for example? We want to make sure that we take into consideration different things like humidity, the dust that makes it up, what type of chemical reaction will happen when it reacts with other parts of the dust collection system. The next one that we look at is the kind of dust size and the physical characteristics of the dust. For example, is it a dust that is sticky or abrasive? Is it a dust that's difficult to collect when it's moving through the ductwork or the airstream? Does it tend to stick together? So we need to choose the correct filter that will be able to handle those types of things. The fourth consideration would be our collection efficiency. So that means with our application, do we have to collect most of the dust, or do we need to collect absolutely the smallest of the particles and get nearly all of it out of the clean air? We want to consider those things, especially if it's hazardous or if it's a toxic material, for example. Maybe we work in a field that's very highly regulated, so we want to make sure that we're collecting as much of the dust as possible, even those smallest particles as well. And then the last consideration that we have would be the price. So we want to make sure that we can meet those needs of our application. And basically, what's the cheapest option? What type of media or fabric will be able to do all of those things for us, but be the most economical in the end? So again, as we mentioned, if you call us on the phone and you look for a different type of filter, or you don't know what type of filter to use for your application, those are the 5 things that we'll generally ask about. And with that, we can help you choose the right type of fabric media for your application so that the bakehouse runs correctly and you're able to, again, collect the most amount of dust possible.
Yeah, good explanation, Scott. Thanks. I would just add too, there's sometimes where we have applications where there's multiple fabrics and things that will work. And sometimes it's a cost benefit analysis. Or then in other applications, there's just alternatives or add-ons we can do. For example, we might add a coating or a treatment, perhaps that'll help with the dust release. We might add a coating like an oleophobic coating to help repel some moisture and oils that are in the gas stream. Maybe not essential for operation, but can make things work a little bit better for a reasonable, uppage in the price, right? And then the cost benefit analysis can make sense there. All right. Matt, maybe you can help me with this one. We had a question about combustible dust and NFPA requirements for dust collection systems. So I know this is kind of a tricky one here. What would your answer be if somebody says, "I want a dust collector that's NFPA rated"? How would you what would you answer back on that?
Sure, pretty common question. So again, the lawyerly answer is you need to be familiar with your local requirements. So there's going to be a fire marshal, an OSHA inspector, whoever it is that your regulatory authority is the ultimate authority for your specific application. Now, that disclaimer aside, there's a few basic requirements for all dust collection systems handling combustible dust. Typically, that would be explosion vents or ventilation on the baghouse itself, some sort of isolation between the baghouse and the process. So an isolation valve on the inlet or the dirty air side of the baghouse. If you're returning air back into the building, you would also need to have isolation on that side. And then you would need to have some sort of an explosion rated or combustible dust rated discharge device, so like a rotary airlock or an NXP or explosion proof drum kit. There are different requirements for a few different applications. Like if you're a wood shop, you got NFPA 564, I think, or 664. There's some special carve outs and exemptions. So that's why I say you really you should be talking with your EH&S people at your site if you have them and your local regulators, because sometimes they will have special carve outs and deals and grandfather clauses and whatnot. You as the facility owner and operator are responsible for complying with that. So we can point you to the NFP requirements and tell you what you need to meet those requirements. And we're happy to do that. We have a whole suite of options we work with through Boss Products. We're a rep for them. So anything you have that's combustible, we can help you be compliant. There's a lot of other little requirements that you might run into, like duct thickness requirements. You can't have really thin little spiral ducts in combustible dust applications, specifically between your isolation or baghouse. We can help you be compliant with a lot of that stuff. So if you ask us to quote a system with combustible dust, we will probably include in the package a number of options, including the vents, the isolation, the explosion-proof discharge device. But we will want to certainly have a discussion with you about what specifically your requirements are for your local regulations so we can make sure we meet those.
Yeah, I think the takeaway there is that the NFPA is not the law. The NFPA is like the fire code, and then the local authority, where that may be, they're the ones that say what the law is for you. And that's why we can never tell you that this system is certified, because we can never possibly know what is required of every single jurisdiction, right? And that's why the end user is the one that has to make the final decisions, right? And I would just say too, right, we have sometimes multiple paths that we can take. What you outlined is what usually makes the most sense, right? That combination of devices. But for example, some applications, they might have a smaller cartridge collector. It might make sense to put it inside and then have something like an explosion chemical isolation or a flameless explosion vent, because then it would keep the dust collector inside. In that special instance, it might be more economical, more practical to do that, because it's a smaller collector. Now, in a big collector, that would be extremely expensive. So the solution you outlined, where it's outside with the isolation valves and the normal explosion vents, that makes more sense. But that's why we also tell people we usually start at this, but then let's talk about the process, and then let's see what we can figure out is the best option for you, right?
Yep.
Um,
And sorry, Dominic, just to add, so
yeah.
we typically there's no need to reinvent the wheel in most cases. So if you have a wood shop system, we're pretty familiar with what the requirements typically are. Spark detection and extinguishing systems. If it's indoor or outdoor, there's typically things we would do. So it depends on your case. There's a whole bunch of options out there, pieces of equipment, and usually there's a best way to do it, and it's been done many times before. So we would point you towards, the normal solution for your type of application.
Yeah, very true. Very true. Okay, well, let's move to another one here. Um, we have here, let's go to maintenance questions. So we had some questions about what are the best practices for dust collector maintenance. I thought maybe if you want to just chime in simply, without going into great detail, but what are some of the most important things or the things that you see that we recommend most often when we go out to do inspections? What would you guys say?
Well, so we have a dust collector maintenance checklist, right? Which we've
Hmm.
given out to a bunch of different people. And whenever I do these kind of things, I always like to deliver that checklist as just like a template because every system's a little different. But the things that are on that checklist are pretty much the same regardless of your system. It's checking your differential pressure, listening to your pulse valves, doing occasional filter inspections, stuff like that. Checking the operation of your fan, belts and sheaves. If you have a screw conveyor, checking your chain drive and stuff like that. There's probably 20 or 30 different items that you can add on there, and you could break up between daily, weekly, monthly or quarterly and yearly items. What's most important is that you have some sort of a checklist, because the
Yeah.
problem that most people run into is nothing really gets done until it breaks. So that's a problem. So even if you have a very simple checklist, which is just do a visual inspection of your bag house once a week, that's better than nothing. We could give you a checklist that'll have very detailed items and it'll make sure that you're good to go. But having some kind of a program in place, some companies have really sophisticated maintenance planning software and stuff. Sometimes it's just a check sheet that's up on the wall in the maintenance shed. But some sort of a process that your people follow is going to be required if you want it to last for a long time. But yeah, the stuff we talked about, cleaning systems, DP, just give it a once over.
Yeah, I like what you mentioned earlier about the DP gauges. It seems like a little thing, but it's so common. It's like on the template for us to make our reports. I've just saved the same language because of the I don't know, 60 site inspections I've done in the last few years. Every single one, I've had a paragraph that is make sure the differential pressure reading is accurate. It's so
Yes.
crucial and it's so often overlooked. And it's they get plugged, the gauges get fouled, and it needs to be in some places it needs to be monthly, every 2 weeks, sometimes every week they need to blow those lines out. And I really like now we have our devices that we sell that are the automatic DP line cleaners. And my goodness, dude, those save money if you put them in because then every few minutes they shoot air back in to blow the line out. And it saves so much headache. Only people would either do that or just make it part of the PM to check those gauges and get them reading. Because sometimes we go out, right? And we ask for the DP readings and we know the numbers are wrong because they've been either they're implausibly low or something, right? Or the gauge is broken. And it kind of hamstrings us with what we can do because we don't know the most important operating parameter of the dust collector, right? What's it running at? And it's not until after we leave, they fix it, and then they send us stuff. Then we can finally kind of make some suggestions and understand what's happening from what we saw, right? So I would say that one, there's lots of that are important, but that one, make sure that's done first, and then everything else you can do, kind of follows that. Um, okay, well, those are all good. We had a question real quick, Matt. Maybe you can answer this one for us about the airlocks and the discharge problems. What are some common things we see with the airlocks, the hoppers, and all of that kind of stuff that cause problems?
So hopper flow problems are really common, and we can always spot them because you go out on site and you look at the hopper and it's all bang. You can see where they've taken a mallet, rubber mallet or a hammer and banged on the side. So it's all banged up and you can, okay, there's a discharge issue that they're dealing with. So a couple things it could be have to do with the dust. If you have moisture in your dust and it sticks to the walls and bridges, that can be a problem. So that should be addressed separately. But more specifically to the discharge equipment. So if you have a rotary airlock, for example, the idea is that you have a leak-free, airtight piece of equipment that provides an airtight divider between the hopper, which is at a certain pressure, and the atmosphere below the hopper, which is at regular standard atmospheric pressure. What can sometimes happen is your rotary airlock, which is a little rotor, it has tips on it, sometimes made from different materials, but they're designed to have a really tight clearance to maintain that leak-free, airtight operation. So the dust falls through, but the air basically stays at its pressure. When those tips wear out, air rushes through there. It becomes a leak source. So now you have air that's coming through your rotary airlock in the wrong direction, and it can cause things to bridge and make it difficult for that dust to discharge out the bottom. So just general condition of your airlocks. Same goes for screw conveyors, although they're a little easier, a little more forgiving on that regard, because the stuff just falls into the screw and gets pushed out. But specifically with rotary airlocks, you got to make sure they're tight and they're operating properly. They have to be designed to the right capacity. So if you're overloading them, that's a problem.
Yeah.
And then generally just there's a few things, little tools that you can use to help get things through the hopper, like vibrators, and worst case, you could weld some strike plates on there. So if you're gonna be banging on it with a rubber mallet, at least you have a welded thick gauge piece that you're not gonna be denting in the hopper. But that's the most common thing we see.
Yeah. Hey,
Yeah,
Scott, what about,
yeah.
yeah, I was just gonna say, what about at the last couple of places we went, we had problems with the hopper. What was that? Mind sharing that?
Yeah, sometimes people think that the hopper is supposed to be full or that there's supposed to be material always within the hopper. The hopper is obviously designed to be able to collect the dust. It does fulfill that purpose, but only on a very temporary timeline, only until it can be released through the airlock, right? Some places that we go to, yeah, you open up the dirty side, and then where the hopper is, it just spills dust. That's a huge hazard if it's anything that could start on fire, obviously. And if the dust is accumulating so much within that hopper, it's obviously not allowing the air to go through that airlock to be discharged correctly. So that could be one of the issues right there, right off the bat, as to why the dust collector isn't working correctly. Some places also, they have so much buildup in the hopper that it's actually pushing the filters and the cages up out of the tube sheet. That obviously is going to be a huge issue. That's going to affect the performance of the bakehouse. So like Matt was saying, we want to definitely keep an eye on things. We want to do things, respectively as well. We don't want to just bang on the hopper and completely, smash it to pieces. But we definitely want to keep an eye on things as well, so we avoid buildup and things like that.
Yeah, excellent. Thanks, Scott. Well, I think I got, maybe for time's sake, maybe we do maybe just two more questions here that we can wrap up. Matt, what would you say? We had some questions that dealt with moisture in the baghouse. How can we control or minimize the negative effects of moisture in our systems?
So if moisture is kind of an innate part of your process and you're stuck dealing with it, then you want to certainly make sure that your filter is the right filter for that application. There are some filter medias and treatments that will help mitigate the effects of that moisture, like PTFE or Teflon coatings, which are basically like your non-stick pan. They're really hard to stick to. So they'll keep even moist dust from coating up your filters, and they're a little easier to clean and stuff. So that's certainly important. If it's a risk, if you want clean, dry air in there, and if you have high temp dust, you want to make sure that you keep it high temp through the entire system and including through the
Exactly.
baghouse. If you have cold spots in your ductwork or in your hopper or your baghouse, you run the risk of that hot dust, dipping below the temperature, where the dew point temperature, where it basically turns into, condensation and moisture. So if you have to deal with hot dust, you need to use insulation and, if necessary, supplemental heating
Mhm.
around your baghouse and your ductwork to make sure you avoid those cold spots. And so that once the dust is out of the baghouse, you can let it cool. But while it's in there and while it's in the ductwork, keep it hot.
Yeah, and that a lot of that comes into too with startup and shutdown procedures, right? When we have temperature changes and moisture, the startup and shutdown are just so crucial to make sure, like you said, we keep it hot
Yeah.
so that there's no condensation in the system. All right, just our last question here. We had a question about undersizing a system. What does it look like when we have an undersized system? Somebody gave us a description that pretty well describes it. He was asking, what does this mean? And the answer is an undersized system. So maybe I can just explain this one. When you have a system that's undersized, like we said, it's a spectrum. It goes from working really well to not working so well to meh to not working at all. When the system's undersized, a few things happen that you'll notice. It'll still be working, but you'll have a lot of times problems with a lot of holes from abrasion, right? You have a lot of abrasion at the bottoms of the bags, especially, and that's because the air speed inside, because you're pushing so much air through a small box, the air speed is so fast that a lot of times it causes more abrasion on the bottoms than we normally would see. But we can verify our system is too small by checking the differential pressure and how it relates to cleaning. So in a normal system, when we size it, we size the bag house so that while you're running at full capacity, however much dust is coming into the collector can be removed by the cleaning system without having to shut down, right? So let's say you've got 1,000 pounds per hour comes in. We size the system so that it can effectively remove 1,000 pounds per hour or a little more without having to shut the system down, without having to turn the fan off. If it's undersized, what happens is 1,000 pounds per hour comes in, only 800 or 900 goes out at a time. And then slowly it kind of gets like overloaded, backed up slowly, slowly. So what you'll see is when you start up, the differential pressure looks normal. It goes up and then you clean and it goes down and then it starts building up again. But as you run for longer and longer, you start getting more and more overloaded. And then eventually you get the DP goes up and then you try to clean more and more and it doesn't quite go all the way down before it goes back up again. And then eventually it does that until it's just high all the time and you're pulsing continuously, nothing's happening until you turn the fan off. And then all of a sudden you pulse and it's like everything comes falling down. This is a sign that it's undersized because those velocities inside are too high for the dust to fall off while the fan's running. So this is why we caution people when they're told that they're supposed to clean down at the end of the day. In most cases, with pulse jet bag houses, in most cases, that's like a shorthand of we undersized it. You need to do this to give it breathing room again. It's like giving it CPR. Because if you turn the fan off, clean everything off, and then turn it back on, it's like everything's brand new again. The problem is then when you're running, right, it builds up and it can't keep up with itself long term. So you can get a system that's undersized, it'll work, but now you're running it in a way you have to shut down periodically, clean it offline, turn it back on. That's incredibly inconvenient, lowers productivity, production rates, right? And that's not how it's supposed to work. So you might save a little bit of money buying something too small, but you end up with those kinds of problems. So hopefully that answers that question that one of our attendees had about what that means when the DP goes high, stays high until you offline clean. That's usually what that's caused by. The system is undersized, or the cleaning system is damaged or something like that. It could be, but usually it's because the system is a little too small for what you're doing with it.